Okay, in this video we'll be looking at factorising non-monic quadratics, so those with a number in front of the x square. We'll use a similar approach, where we start by expanding and then reverse engineer it. So here we get 2x times 4x is 8x square, 3 times 4x is 12x, 2x times 5 is 10x, 3 times 5 is 15. And once again we can simplify this, where 12x plus 10x is 22x, and everything else just comes along again. So once again, we want to pretend we're only given the end result, and we want to recover all the things inside the brackets. Something that works in much the same way is that these two constant numbers in the brackets need to multiply to give the constant 15 at the end there. But now something really similar happens for the leading term actually, where the 2 and the 4 that sit in front of the x, they need to multiply as well to arrive at the 8x square, the first term, the number in front of the x square. So that's going to open up a lot more possibilities when there are two numbers to break into factors. Okay, and now like for the monic case, the 22x came from addition, from 12x plus 10x, but where did they come from? Well, the 12 came from 3 times 4 between the brackets, while the 10 came from 2 times 5 between the brackets. Okay, so that describes all the patterns, but coming up with those bracket numbers isn't always easy. Now, there are some interesting methods for this. I prefer not using any of them. Okay, I'll leave a more detailed reason for why in the description. But what you're going to see is that we're going to build the tower of factors for both the leading term and the constant term. And we're going to find a way to build that middle term by multiplying and adding in that pattern that we just saw. Okay, so for this example, it was 2 times 5 plus 4 times 3. Okay, once again, I don't expect you to actually draw those factor possibilities. All of that should happen in your head, and it's once more a case of practice, okay? Alright, so let's see some examples. So here's the thing we're trying to factor, so let's make some empty brackets. We start by thinking through factors of the first and last numbers. So for 6, we have 1 and 6 and 2 and 3. For 10, we have 1 and 10, 2 and 5. I'll try and talk you through what would be happening in my head. Okay, I'd start by sort of eliminating extreme cases. Okay, so if I multiply 1 and 10, I'd get 10. But if we took this, we'd be forced to take 6 times 1 as well. That'd be the other multiplication between the brackets, okay? But that's 6, and they total to 16. Which is close, but not quite what we're looking for. Okay, but if we look at all the other options for this 10, the totals are way too high. We have overshot. So we'd exclude the 1 and 10 option. Okay, and now you'll eventually get a feel for this, and that whole process of not even thinking about the 1 and 10 option, okay, should happen in the first second or two. Okay, with seeing the question, you should be able to discount that possibility within the first second or two. Okay, but the advantage now is we can actually immediately fill in the plus 2 and the plus 5. And that now doesn't leave us with very many options to try. So we'd have these ones giving 32, it's no good, these giving 17. And here we hit the 19 we're looking for. Okay, and so the 2 and 3 go in. And the order is important. You need to make sure the numbers will multiply correctly to get the 15x and 4x, adding up to the 19x that we're targeting. Okay? Alright, before we do one more, I can't stress enough that I'm just doing my best to visualize my thoughts here. All of this happens in your head. Okay, and while it might be a bit challenging to start with, you'll start building your intuitions and your gut feeling for what's more or less likely to work, and it should get faster as you do more of them. Okay, so here's another one. We'll set up the brackets first, and then factors again. Factors of 4 are either 1 and 4, or 2 and 2. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. Once again, you can quickly check yourself, but I'd be pretty quick to discount the 1 and 12 option, because having to multiply by 12 will generally be way too big for this. Okay, occasionally these gut feelings might be wrong. That's totally fine. We just come back and check it at the end, in case we missed the correct option. But be safe to discount the 1 and 12 for this one. Okay. Next, I'd want to pick between 1 and 4 and 2 and 2. Okay, what gives us a huge hint here is the fact that the 12 is actually negative, which means, like for the monic case, our total will be made of one positive number and one negative number. Okay, the numbers will be working against each other. But the target in the middle is 13, which is relatively large. So for that to happen, I'm willing to bet that it's more likely to be 1 and 4 than it is to be 2 and 2. And more than that, the 4 better be multiplying with the positive number, and the 1 better be multiplying with the negative number. That seems to be the only way the total difference can be such a big positive result. Okay, the plus 13 that we're targeting. So we try that over 2 and 2, I think. I guess also 2 and 2 is only capable of producing even numbers, so 13 is actually impossible, but that's like ultra instinct stuff, okay? But often the relative sizes of the numbers is quite informative too. And at this point, it'd be a matter of trying them till they work, okay? Although again, ultra instinct tells you that you must take an odd one to have an odd result, which really locks it down to being the 3 and 4, and in that order too. But we can check. 4 times 4 is 16. Negative 3 times 1 is negative 3, so the total is indeed positive 13, so we're good. Okay, so that's all for this one. Probably will take a fair bit more practice than the monic case, but I reckon it's quite nice actually for continuing to develop some good number sense anyway. Okay, so thanks for watching, and see you around.